So now we're going to go over the second half of this worksheet, which deals with the molar mass of molecules. And so in our first question here, consider the molecule methane with the formula CH4. And so really what we're dealing with is this formula CH4 and really understanding what this means. So our first question is how many atoms of carbon are present in one molecule of methane? So if we have a single molecule of methane, what this formula CH4 tells us is there's one carbon and 4 hydrogens attached. So how many atoms of carbon are present? There's one atom of carbon. How many atoms of hydrogen? So we see a subscript 4 next to the hydrogen. That means there's 4 different hydrogen atoms. So we have 4 different hydrogens. If we have how many atoms of carbon are present in 1 dozen molecules. So if we had a dozen molecules, if you had an egg carton of methane, how many carbons? And so we can think about this. You might be able to do this in your head, but to sort of write this out, if we had 12 molecules, right, 1 dozen, then for each molecule, there's 1 carbon, so we'd end up with 12 carbons. Right, so all I did was take the 1 carbon per molecule and multiply by the number of molecules, in this case 12. You can do the same thing for hydrogen. How many atoms of hydrogen are present in 1 dozen molecules? Well, if we have 12 molecules and there's 4 hydrogens per molecule, we would have 48 hydrogen atoms. So part E, how many hydrogen atoms are present in 1 mole of methane, right? So 1 mole is just a number, just like a dozen, right? So in the first case was how many in a dozen, now it's how many in a mole. So now we're just going to start and say, well, what is 1 mole? 1 mole is 6.023 times 10 to the 23rd, right? In this case, we're going to have atoms, and then we see there's 4 hydrogen atoms per molecule. Right. And we're going to end up with, we can multiply that out. We get 6.023. Oops, figure this out. 6.023 second E, 23 times 4. And we get 2.41 times 10 to the 24th. 2.41 times 10 to the 24th. And this is going to be atoms of hydrogen. Right, because in 1 mole of the molecule, we'd have a mole of carbon and 4 times that moles of hydrogen. All right, so in part F, now we're going to deal with the relationship between mass and moles. What is the mass of 1 mole of methane? So in order to find this, we have to recall that methane is made up of carbon and hydrogen. And we have to think about that carbon. We're going to have to look up the molar masses. So if we go to the periodic table for a second, we can find our elements. Here's carbon, and here's hydrogen. And we're going to need to know what is the mass of hydrogen per mole and what is the mass of carbon per mole. So those are the two numbers, 1.008 and 12.01. So I'm going to write those down on my paper. So 12.01 grams per mole, 1.008 grams per mole. So that is the mass per mole, but we know in methane, which is CH4, the molar mass will be the sum of all of the atoms. So we're going to have 12.01 grams per mole plus, and we're going to have our 1.008 grams per mole. However, there's 4 of these, So I'm going to multiply that by 4 because there's 4 hydrogens. And then the sum of that will be the molar mass of our methane. So we can say 12.01 plus 4 times 1.008, and that's going to be 16.04 grams per mole. And that is the molar mass of methane. So if we had 1 mole of methane, it would weigh 16.04 grams. All right, we can see this is the molar mass. And the next question we're asked, calculate the mass of 2.85 moles of methane molecules. So here, again, we want to go from grams, the other way. We're going to go from moles to grams. So we're going to start with that 2.85 moles of CH4. And now we have our relationship where we know that each mole of methane weighs 16.04 grams per 1 mole. So we can multiply that out and determine the mass. So 2.85 times 16.04 equals 45.7 grams. In part H, then we're asked how many molecules of methane are present in 2.60 grams of methane. So again, this is a two-step problem. We want to get to molecules, and we're given grams. So we can think about how we're going to get there. So if we want to go to number of molecules, the way we get to number of molecules is from moles. And the way we get to moles, we can get to from grams. So we're going to start off with our 2.60 grams of methane. And we're going to convert that to moles. So we have moles up top, grams on the bottom, 16.04 per 1 mole. And now, if we stopped now, grams would go away and we'd be left with moles. But we want molecules. So what I'm going to do now is say for every 1 mole, there's 6.023 times 10 to the 23rd molecules, right? So Avogadro's number just tells us the number of things per mole. And so we can do this all out on our calculator. Pull up that calculator again, and we get 2.6 divided by 16.04 times 6.023 second e 23rd. If you don't use that e function, you need to use parentheses around that number. And so we see we get 9.76 times 10 to the 22nd molecules. All right. There's 3 more problems here. And so here we're asked to do a couple things. We're asked to convert the moles present in 1.5 grams of dry ice. All right, so we're given grams, so 1.50 grams. And we want to convert grams into moles of this CO2. So in order to go from grams to moles, grams divided by 1 mole, what we're going to need to do is find the molar mass. And that's going to come from the periodic table by adding up the carbon and the 2 hydrogens. In the second problem, we're asked to find the moles and given the number of molecules. So we're going to start with the number of molecules, 2.72 times 10 to the 21st molecules. And here, we want to end up in moles. So what's our relationship between molecules and moles? We want moles up top. And so in this case, we're going to use Avogadro's number, 6.023 times 10 to the 23rd molecules per mole. And that'll give us our answer in moles. And then in the bottom problem, we're asked what is the mass in grams if we start with 0.338 moles. So we need to start with that 0.338 moles. And we want to go to grams. So that conversion factor again, grams we want to keep, moles we want to go away to get our grams of sucrose. And that missing number on the top of our fraction here is going to be the molar mass of sucrose, which again, we're going to have to calculate from the periodic table from that formula. So I'll leave those set up for you and let you try those and check your answers. Thank you.